Hello students, welcome back. Now we are going to do the examples with respect to the arithmetic progression. So let's start with our first example. Here what it's trying to say is that for the arithmetic progression, write the first term A and the common difference. So here what it's trying to say is to identify A and D, which is the common difference. So how do you identify the first term? First term is the first element of the arithmetic progression. As you can see, it is 3 by 2. 3 by 2. And what is the common difference? How do you find the common difference? Common difference is second term minus the first term. Okay, so let's say the LCM is 2, 1 minus 3 minus 2 divided by 2, which is equal to minus 1. So these are some very simple examples. As we proceed, we might come with a little bit more complexity. As we proceed, we'll learn about in detail about it. I hope this is clear, this example. Let's move to the next example. Okay. So read this. Which of the following list of numbers from an arithmetic progression? If they form an arithmetic progression, write the next two terms. Okay students, so now earlier example we know that it was already given as the given sequence is arithmetic progression. Here the question is they are asking whether it is an arithmetic progression or no. How do we know that this is an arithmetic progression? The simple way is to find the difference. For example, between the first two terms are next second and third term are fourth or third term. So let's try to identify now. Okay, so we have 4, 10. Okay, so 10 minus 4 is what? 6. Okay, then let's take another next term, 10 and 16. 16 minus 10, difference is 6. Let's take another example, 22 minus 16. What it is? 4 plus 2, 6. So here we can see the common difference is coming as 6. So D is 6. Okay students, from this we can see that it is an arithmetic progression. So from this example we know the next question, the next part it says is next two terms. We need to identify the next two terms. So is this an arithmetic progression? Yes, it is an arithmetic progression. So we have what are the values we have? We have A, which is 4, we have D, which is 6. Okay, so we need to find two terms. So we have been given 1, 2, 3, 4. The fourth term has been given, so we need to find fifth and sixth term. So A 5 and A 6. Okay, so how do we find? We have a formula called AN is equal to A plus N minus 1 into D. Okay, so if you say A5, so what is A? A is 4 plus N. N is 5. 5 minus 1 is 4 into D. D is 6. Okay, 4 plus 4 6 24. Okay, 24 plus 4 is 28. So the fifth term is 28. Okay, so like this let's try to find out the sixth term. What is A here? A is 4 plus what is N here? N is 6. 6 minus 1 into D. What is D here? D is 6. Okay, so 4 plus 6 minus 1 is 5 into 6. 4 plus 5, 6 are 30. So it becomes 34. A sixth term is 34. So the sequence becomes 4, 10, 16, 22, 28 and 34. This is a sequence arithmetic progression. I hope this is clear. Let's move to the next question. Okay, so here we need to find the first term. And okay, so we know what is the first term here. A is equal to 1. Okay, so let's try to find the d. D is second term minus first term. What is the second term? Minus 1 minus of 1, which is equal to minus 2. Okay, so let's see let's take another example. Okay, so third term minus second term. What is the third term? Third term is minus 3 minus of minus 1, which is equal to minus 3. Minus into minus becomes plus 1. Okay, so this becomes minus 2. So you can see the common difference. Hence this is an arithmetic progression. This particular sequence is an arithmetic progression. Now we need to identify the next two terms. What are the next two terms? 1, 2, 3, 4. Fourth is given, so we need to find fifth and the sixth one. Okay, so how do we identify? Okay, A5. So what is the A? So we need to find A plus 4D. What is A here? A is 1 plus 4 into D. D is minus 2. Okay, 1 minus 4, which is equal to minus 3. Sorry, 1 second, I need to erase all this. So this is multiplication, right? Minus 2. So 1 plus into minus becomes minus. 4 2s are 8. Minus 7. Okay, I misunderstood this. Okay, so here let's find A plus 5D. What is A here? Is 1 plus 5. What is the difference here? Difference is minus 2, which becomes 1 minus 5 2s are 10, which becomes minus 9. Okay, so henceforth our arithmetic progression here, and the two terms, this is an arithmetic progression, and the two terms are minus 7 and minus 9. Okay. Okay, student, let's move to the next example. Okay, so here also we need to find first thing whether it is an arithmetic progression or not. So we know A is equal to minus 2 from the given sequence. To make this, prove this as an arithmetic progression, its common difference should be equal. Okay, so let's try to find from the second term difference from the second term with the difference from the first term. What is the second term? 2 minus of minus 2, which is equal to 2 minus into minus is plus 2, which is equal to 4. Okay, so here the difference is 4. Let's see. Let's take now the third term minus the second term. Okay, what is the third term? Third term is minus 2 minus of 2. Okay, so minus 2 minus into plus is minus 2, which becomes minus 4. Oh, so here there is a difference. Here it is minus 4 and here it is plus 4. So hence the common difference D is not equal or not constant. Hence this particular arithmetic progression is, it's not an arithmetic progression. With this, hope this is clear. Okay, students, let's move to our next question. Okay, so here also we need to find, first thing is we need to see whether this is an arithmetic progression or not, and second thing is we need to find the terms. First, let's see whether it is an arithmetic progression. If you see here, by looking at the question itself, there is something different here. Earlier we used to have 4, I think max 4. Here you can see the entry is more, so there should be something different. So it is a hint. Then let's try to find the difference, common difference. A2 minus A1. So what is A2? A2 is 1, and minus of A1 is 1. Okay, 1 minus 1 is 0. Okay, so let's take another example. A3 minus A2. Okay, so what is A3? A3 is 1, minus of A2 is 1. So the difference is 0. So usually we are taking 2 examples, but by looking at this, you need to consider one more thing. Understand there is something trivial here, the pattern is different here. So by looking at this example, it looks like it's going to be different. So let's take another example wherein we'll take, here there is a difference, A1, A2, A3, A4. Let's take A4, okay, A4 minus A3, okay. So what is A4? A4 is 2 minus of and 1. So the difference looks to be 1, okay. So this is not common, this is not common. Okay, so the reason why I have picked up here is, by usually we take 2 examples and identify that it's an arithmetic progression. So you need to be cautious. This is simple but little bit tricky here. If you take just 2 terms and try to find the difference, it might look like okay, it is an arithmetic progression. But just be cautious when you have something which is increasing and there is a different pattern. So just have a glance on this. So hence, since the d, the common difference, is not equal, okay, is not constant, and this is not an arithmetic progression. Okay student, let's proceed to another example. Okay, so what it says, find the 10th term of an arithmetic progression. That means it's clearly given this is an arithmetic progression, so we don't need to prove that it's an arithmetic progression. So we need to identify the 10th term. So what we have a formula called, if you want to identify, an is equal to a plus n minus 1 into d. Okay, so what it's saying, to identify the 10th term, okay, n is equal to 10. We have a, what is a here? 2. Okay, let's try to identify here. Okay, let's write it down. A is equal to 2. Then we need to identify the d. So let's try to identify the d. Okay, 7 minus 2, which is equal to 5. Okay, let's take another term, 12 minus 7, okay, is equal to 5. So we can find, don't need to find the 2 sequence here because it's already said as arithmetic progression. With the first difference itself we can proceed. Okay, just to show that I have put it. So what is the value of a? Value of a is 2 plus n. N is nothing but 10. 10 minus 1 is 9. Okay, 9, and the difference is 5. Okay, so 2, what is 9 5s are 45. Okay, so sorry, 47. So A's 10th term is 47. Hope this is clear, guys. Okay students, let's move to the next question, next example. Okay, so what is trying to say here, which term of an arithmetic progression. So one thing is confirmed, we don't need to find this is arithmetic progression. This is already defined as arithmetic progression. Okay, so in this particular arithmetic progression, okay, is, let's try to read it. Okay, this is an arithmetic progression, is 81. Oh, okay, so the question here is this 81. Okay, so let's try to solve it. So we have 2 question marks here which we need to solve it. Okay, first thing is here minus 81. So minus 81, so also is any term 0. So we need to give a reason for our justification. So let's try to find minus 81 belongs to which term. Okay, so with this we can find, how do you find when the an, we have a formula an is equal to a plus n minus 1 into d. So in this, what are the variables? We have given an is equal to, you can consider an is equal to minus 81. Okay, do we have a? Yes, we have a is equal to 21. Do we have difference? Yes, we can find the difference. Difference is okay, so we have a difference here. Let's try to get the difference here. 18 minus 21, which is equal to minus 3. Okay, so we have the difference here 3. So let's try to put it. An is equal to, let's try to solve this. Okay, so an minus 81 is equal to a, what is a? 21 plus n. So n is the one which we need to find its position. Okay, so let's put n minus 1 into d is minus 3. Minus 81, if it goes here, it becomes minus 21, goes here, it becomes minus 21. Then we have 3n n minus into plus becomes minus into minus becomes plus 3. Okay, minus 81 minus 21, if you bring here this, it becomes minus 3 is equal to minus 3n. Okay, so let's add it. Minus 105 is equal to minus 3n. Okay, let's try to put my 105 divided by minus 3 is equal to n. Minus minus gets cancelled. 3 ones are 3, 35 times it goes. So n is equal to 35. Okay. Okay, students, so we have proved half. So next half, let's try to prove. Also, is any term 0? So here what is trying to say is that, okay, let's bring it up. Similarly, we need to say, so is any term, so an is equal to 0. So we can use the same formula. Okay, an is equal to a plus n minus 1 into d. In this variables, what not we have? Yeah, we have almost all the things. Okay, so let's try to put it. An is given as 0. A is, what is a? 21 plus n. N is the one which we need to identify. N minus 1, and what is the difference? Difference is minus 3. Okay, so let's move this 21 towards left side. It becomes minus 21 is equal to n minus 1 into minus 3. Okay, so here let's bring minus 21, this 3 over here, minus 3 is equal to n minus 1, gets cancelled. 3 ones are 3 sevens are. Okay, so we have n minus 1 is equal to 7. N, let's move this 1 towards this one. 7 minus becomes plus 1, which is equal to 8. So we have the 0 term in the sequence, and its term is 8 term. So let's see if it fits. Okay, so this is nothing but 8th term. 8th term in this particular AP. Hope this is clear, students. Let's move to the next question. Okay, students, so here we have another example. What it's trying to say is, determine the AP whose third term is 5 and the seventh term is 9. So here the terms have been given of an AP, but the AP, complete AP is not given. So what they're saying, our aim is to get the AP. So how do we get it? So here A of 5. Okay, so the third term A of 3 is equal to 5, and the seventh term A of 7 is equal to 9. These are given. Okay, so we know the formula to find out the terms. Okay, so A3 is equal to A plus 2D, A7 is equal to A plus 6D. So we know what is the value of A3. A3 is given as 5, and same here, A7 is given as 9. So this we can say it as A plus 2D is equal to 5. Then we have A plus 6D is equal to 9. So we have two equations here, 1 and 2. So usually we need to find the first term and the difference. So now we don't have, but we have two equations. By solving these two equations, we will get the value of A and D. Let's try to solve it. A plus 2D is equal to 5. Similarly, A plus 6D is equal to 9. Okay, so we need to subtract it, otherwise we will not be able to sort it out here. Okay, so 5 minus 9 is what? 4, which is minus 4. Okay, so plus A minus A gets cancelled. Okay, so you have 2 minus 6, which is equal to minus 4D. Okay, so minus 4 get cancelled. D is equal to 1. So we got D. So let's try to put this D in one of the expressions. A plus 2D is equal to 5. In this we know A, we know D, which is 2 into 1 is equal to 5. A plus 2 is equal to 5. A is equal to 5. If you take it right side, it becomes minus 2, which is equal to 3. So we know A is equal to 3. So with this, can we identify the sequence? Yes. Let's try to find. What is A? A is equal to, so we know A comma A plus D comma A plus 2D. You remember, this is the general form of an arithmetic progression, A plus 3D. So A is equal to, A is here 3 plus what is the difference? 1 comma A 3. What is it? 2, difference is 1 comma A is 3 plus 3, difference is D 1. Okay. Sorry. So let's see what it is. 3 plus 1 4, 2 3 plus 2 5, 3 plus 3 6. Let's move to the next question. Okay students, so let's see what is our next example. Check whether 301 is a term of the list of numbers. Okay, so this is an arithmetic progression. So does 301 belongs to this progression? Is the question here. Okay, so to find that, we'll use the formula an is equal to a plus n minus 1 into d. Why? Because you can see this is the n term. We don't know which term it is, whether it belongs to this or not. So let's assume an is equal to 301 and proceed it. Okay, so do we know the A? Yes, we have the value of A. Do we know the D? Yes, we have the value of D. So for example, 11 minus 5 is 6. Since it's already mentioned as arithmetic progression, so I'm assuming this is I'm not going for the another terms differentiation. Okay, so let's see an. So an is equal to 301 is equal to a is 5 plus n minus 1 into 6. Okay, so 301 minus 5 comes here, then n minus 1 into 6. Okay, so it becomes 296 equal to n minus 1 into 6. So let's see, 296 divided by 3 is equal to n minus 1. Okay, so does 3 goes? Yes, it goes. 148. Okay, so 148 148 divided by 3 plus 1 is equal to n. This n minus 1 we are expanding, bringing the minus 1 here. So it becomes 3, 148 plus 3 is equal to n. Okay, it becomes 151 divided by 3, which is equal to n. Okay, so here we can see that it is coming as a fraction. So our arithmetic progression doesn't come in the fraction format. So hence we can say that n is in fraction, hence 301 does not belong to the AP. Hope this is clear. This 301, we have checked that it is not part of the term. The reason is it cannot be if it is a negative or it's a fraction. Okay, so let's move to the next question. Okay, so let's try to understand what exactly is saying. How many 2-digit numbers are divisible by 3? So in this, it's quite straightforward. The question, by looking at this question, you can understand it's trying to find the sequence. Okay, how many 2-digit numbers are divisible by 3? Okay, so 2 digits. So we know that what are the, let's try to find divisible by 3 is nothing but the multiplication. So it will be 3, 6, 9, 12, 15. It proceeds 2 digits. The last 2 digits can be till 99. Okay, so this comes under the table 3. Okay, so it says here we need to see that it's 2 digit. So 2 digit here is starting is 12. Okay, multiples. Okay, 2 digits. So 12, 15, 18, and it keeps continuing. So we know 99 is divisible by 3. So let's put the last term as 99. So let's try to solve this here. What are the things which we know? We know A. What is A? A is 12. What is D? Let's try to find D. D is nothing but 3, since it's a multiplication of 3. Divisible. Okay, 3. And what else we have? We have an. The last term we have an is equal to 99. Okay, so by looking at this, which of the formula we can use to find the n term? Okay, so n, do we know n? Do we know n? No, we don't know at what position it comes. So let's try to find using the standard formula an, nth term. A plus n minus 1 into d. So an, okay, an is 99 is equal to, okay, so A we know is 12 plus n minus 1. What is D? D is 3. Okay, So let's see, 99 minus 12 is equal to n minus 1 into 3. Okay, so 99 minus 12 becomes 9 minus 2 is 7, 87 is equal to n minus 1 into 3. Okay, so let's bring this back, 3 over here, 87. So let's bring this 3 over here, it gets divided, 3 is equal to n minus 1. Does 3 goes in 87? Yeah, so 90 is nearby, so it goes 329s. Okay, so 29 is equal to n minus 1. Let's take this page further. Okay, 29, this minus 1 comes here, it becomes plus 1 is equal to n. So n is equal to 30. So hope this is clear. Okay, let's move to the next question. Okay students, let's try to solve this example. Find the 11th term from the last term towards the first term of the AP. Don't worry, it's just trying to confuse you here. Find the 11th term from the last term. So the last term is here 62. So from here we need to find. Okay, we need to find the 11th term from here. So instead of that, what we'll do is we'll reverse this AP itself. Let's put it as minus 62 dot 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 10 7. No, 1 second, let me just correct it. So it will be 4 7 10. Okay, so now we know the nth term. Nth term is a is equal to, first term we know a is equal to minus 62. Do we know the difference? Yes, we know. Let's try to find, this is the easiest way. Since this is already an arithmetic progression, we don't need to worry, we can take any of the terms, second or first, and try to find the difference. 10 minus 7 is equal to 3. So we know D, which is equal to 3. Okay, so what is being asked? So we need to find the 11th term, which is equal to A11. So we have a formula with which we can identify n term. An is equal to A plus n minus 1 into D. Okay, so let's try to replace here. A11 we have it. Okay, we need to find the A11th. Okay, in term, 11th term. Okay, A, do we know the A? Yes, we know A. A is equal to minus 62 plus n minus 1. What is n here? N is 11. 11 minus 1 is 10. 10. D is 3. Okay, A11 minus 62 plus 30. A11. So minus 62 plus 30, how much is, student?
Wait,
so it is minus 32. Good. Okay. So we know that A11th is equal to minus 32. Hope this is clear. Simple here. It's just trying to confuse you, saying that 11th term from the last term. So just reverse the arithmetic progression and everything looks fine. So when it says as arithmetic progression, you can just find the difference of first two terms. You will get the difference. When it is check or whether, those sort of words are being used, be careful. So we need to identify whether it is arithmetic progression or not. Okay, if it is an arithmetic progression, it has to have the constant difference. Okay, so let's move to the next example. Okay students, let's try to analyze this particular example. A sum of rupees 1000 is invested at 8% simple interest per year. Okay, calculate the interest at the end of each year. Okay, do this interest form an arithmetic progression? If so, find the interest at the end of 30th years making use of this fact. Okay, So basically, don't get nervous with this question. The reason is we were trying to do the arithmetic progression, and how come the sum of 1000 invested is basically it's trying to calculate the simple interest. So simple interest is a sequence of simple interest. Can I say that this arithmetic progression is nothing but a sequence of simple interest? What is arithmetic progression? It is nothing but the sequence of numbers. So here the numbers is nothing but the simple interest. So let's try to find out what is simple interest. We know the formula of simple interest is equal to principal interest into rate of interest into time divided by 100. Okay, so let's try to see with the given data what exactly. Eventually we need to find whether this is an arithmetic progression or not. To find an arithmetic progression or not, we need to have the sequence of numbers. Here the numbers are nothing but the output what you get for the simple interest. Okay, then we'll see the next steps. Okay, so let's try to calculate here the simple interest for the first year. Okay, so we have P 1000 into rate of interest is 8%. Okay, and term is per year, that means first year, so 1 divided by 100. Okay, 2 zeros gone. This will be 80. Okay, so this is for the first year. Let's try to calculate for the second year. So same, it remains the same, 1000. It's just this term is going to change. 8 into 8 into 2 divided by 100. 0 gets cancelled. So we know earlier we got 80 and the difference is 2 only here. So it will be 80 into 2, 160. So like that, the third term. So can we identify by looking at this? Yes, we can, but let's try to calculate it here. 1000 into 8 into 3 divided by 100. Okay, 2 zeros gone. 10 8 is 80, 83 is 240. Okay, so we got this, okay, input. So let's try to see. Okay, let's try to write the output what we got. We got 80 for the first year, then we got 160, then we got 240. Okay. So with this, first of all, with this, calculate the interest of the end of the year we have done. Do this interest forms an AP. So the simple interest what we got, does this form an AP? So for it to be an AP, we need to have the common difference. Okay, first of all, it fulfills the simple, it's a sequence of numbers. So let's try to find E2 minus A1. What is E2? It is 160 minus 80. The difference is 80. Let's see, E3 minus E2, which is 240 minus 160. The difference is 80. Okay, so this is having a constant difference. So the D is same here. Okay, so we have the common difference. Okay, so with this we have seen that this is an arithmetic progression. The simple interest which is being formed is an arithmetic progression. Okay, this fulfills the arithmetic progression. So now let's try to understand this other part of the question. If so, find the interest at the end of 30 years making use of this fact. Okay, so it is saying that the nth term here is 30. Okay, so let's try to find. We have a formula. With this we can identify. Okay, so an is equal to a plus n minus 1 into d. Okay, so what is an? A of 30 is equal to a. Do we know a? Yes, we know a. 80 first term. N, do we know n? Yes, 30 minus 1. Do we know the difference? Yes, we know the difference, 80. Okay, so 80 plus 29 into 80. Okay, so we have 80. So students, calculate this. 29 into 80. So 2300. So 2 2 3 2 0. Okay, so now if you add it, it becomes 2400. So this is the 30th term and its value is 2400. Okay students, so let's see, is this the one? Yeah. And if you see that there is another example here, if you can see here, first, second, third. So third term is 240. So if you multiply the third term into 10, you will get the same result. Hence we have proved all the questions which is been asked here. Okay, so if any questions, let me know. Thank you. Let's move to the next question. This is pretty straightforward. So just try to understand here what is saying. So it's saying arithmetic progression. What is to be there for the arithmetic progression? Sequence of numbers. So that numbers here is nothing but a simple interest. Does this simple interest forms an AP? How do you say that it is an AP? By finding the common difference D. Okay. So now when you have A, D, you can make use of the nth term formula identifying. So any term which is given. So here they are asking us 30th term. So that we have done and identified the solution. Okay, let's move to the next question. Thank you. Try to analyze this particular example. In a flower bed, there are 23 rows plants in the first row, 21 in the second row, 19 in the third row, and so on. There are 5 rows plants in the last row. Okay, how many rows are there in the flower bed? Okay, so there is a flower bed forming. So first row is something like this. You have 23. Okay, in the second row you have 21. Okay, in the third row you have 19, and like that the last row has been given. In this 5 is there. Okay, so we can say that those are 5 rows plants in the last row. Okay, so last row it is mentioned as 5. Okay, how many rows are there in the flower beds? Okay, so we need to identify how many such rows are there. Okay, so 1 2 3 and like this the last one is there. So last one is known. So for example, here we know first one is 23. Okay, and the last one is, we don't know the which number of that, how many rows are there, we need to identify it. So that's why the n is unknown here, but we know the nth position, the last term, we have the value as 5. Okay, so let's try to find the D here. Okay, so D is 21 minus 23 is equal to, since it's capital, bigger, minus 2. Okay, so we have D. So we know how to find the value of n by the formula nth term. An is equal to A plus n minus 1 into D. An is equal to 5. E is equal to, what is it, 23 plus n minus 1, and D is minus 2. Okay, 5 is equal to 23. Okay, so let's do one thing. Okay, let's take this 23 here. 5 minus 23 is equal to n minus 1 into minus 2. Okay, so 5 minus 23 is 18, which is minus 18 is equal to n minus 1 minus 2. Okay. So here let's see minus 18. Let's bring this minus 2 towards this side. Minus 2 is equal to n minus 1. Minus minus gets cancelled. 2 1s are 2 9s are. So 9 n minus 1, which is, so n, let's bring this 1 towards this side, because plus n is equal to 10. So there are 10 such rows. So we found, and the value of that is n. Here we found 10. Hope this is clear, students. Let's move to the next question. Okay, students, so let's see this example. Find the sum of first 22 terms of arithmetic progression. Okay, so here we are seeing the sum of the arithmetic progression. So till now we were finding the n term, en, r, the n. So here we need to find the sum of the terms. So here it says 22nd term. So we have the formula, okay, Sn is equal to n by 2 2a plus n minus 1 into d. Okay, so what now we have? We have a is equal to 8. We have d, which is nothing but 3 minus 8, which is equal to minus 5. Okay, and we have the n is equal to 22 as per given in the question. So now we need to just replace the values here. Okay, S22 is equal to 22 divided by 2, and what is the value of a is 8, plus n, we know n 22 minus 1, and d is minus 5. So here 2 11s, okay, so 11, you have 2 8s, 16 plus 21 minus 5. Okay, so let's simplify further. 11, 16 plus minus 21 5s are 105. Okay, so let's further 11. Okay, how much it becomes if you remove 16 from 105? The sign will be minus. It will be 89. Okay, so let's see 11. Okay, 1189. So let's try to multiply 89 into 11. 89, 9, 16, 17, 1, 9. So 9, 7, 9. We have a sign, so don't forget this, minus 11. So the S22, the sum of 22 numbers is minus 979. Okay, students, so this was one of the first question which we got in our examples related to the sum of the terms. So here the term was being asked was 22. So if you know this is the formula, just remember this, and there is another formula for the sum when you know the last term. So let's see the example as we proceed. Let's move to the next question. Okay, student, let's analyze this particular example. What is trying to say here? If the sum of the first 14 terms of an AP is 1050. Okay, so here it's talking about the sum of the nth term. So here the nth term is 14 of an AP. Its value is given. Its first term, so A is given. Find the 20th term. So nth term here to be found is 20th term. So we know when we are dealing with the sum, we have a formula called Sn is equal to n by 2 whole bracket 2a plus n minus 1 into d. So in this, what are the variables we know? n. Do we know n? Yes, we know n. N is what? 14. Okay, so do we know Sn? Yes, we know Sn. Sum of that is given 1050. Okay, so we know this. Do we know A? Yes, A is given. A is equal to 10, first term. Okay, so do we know the n here? N minus 1. Okay, so we have n. Okay, so this is the one unknown variable. Okay, why? Because if you need at least 2 to 3 terms to see the difference. So here we don't have the term, so d is unknown here. Okay, so in this, okay, almost this. So let's try to replace here the value. Sn is equal to 1050. N is equal to 14 divided by 2. Do we have 2? A is equal to 10. Okay, plus n 14 minus 1. D is unknown, so let's put it same thing. Okay, so let's try to see. 2 ones are 7s are 7, 2 10s are 20, plus 14 minus 1. Let's try to simplify here. 13, 14 minus 1 is 13, D. Okay, so we have 1050. So let's take this 7 outside and divide here. 7 is equal to 20 plus 13 D. Okay, so student, let's see whether 7 goes in this. 7 ones are. Let's try to calculate here. Okay, so we have 150. Okay, so let's say 150 minus 20 is equal to 13D. So how much it is? 130 is equal to 13D. Okay, so 13 ones are 10s are. Okay, 10. D is equal to 10. Okay, so we have the unknown variable, which was D. Here we have the value D. So now we need to find the 20th term. So we have all the values. So let's try to replace here. How do you identify the nth term? So it's asking for the 20th term, which is A of 20. Okay, so we have a formula. An is equal to A plus n minus 1 into D. So A 20 is equal to 20 plus, what is n here? So let's see, the n is 14. Okay, sorry, n is 20 here. So this is the n which we need to see. 20 minus 1 is 19 into D. D we got is as 10. So A of 20 is equal to 20 plus 190. I think I have done a mistake here. A is what? Okay, A is not 20. A is 10 here. Sorry guys, A is not 20. So let me just erase this off. Okay, let me take this. Okay, A value is 10 here, not 20. So A of 20, A is 10 plus n is 20 minus 1. Okay, where is D here? D is missing. D we got it as 10. Okay, 10 plus 19 into 10. 10 plus 190, which is equal to 200. A of 20 is sorry, it's 200. Okay students, so this is clear, quite simple. We need to just understand here it says the sum, so what are the unknown variables we have, and in that formula one of the unknown variables we identified. Once we identified the difference, then we went ahead with the nth term finding. Okay, let's move on to the next question. Okay, so let's try to analyze this particular example. It's an arithmetic progression which is of this sequence. Okay, what is this? How many terms of the AP must be taken so that their sum is 78? Okay, so we have sum, the formula for sum Sn of sum is 78, of which term we don't know, n we don't know. Okay, do we know A? Yes, first thing we find is A. Do we know D? Yes, there are multiple sequence, so we can identify D. So let's try to find 21 minus 24, which will be equal to, since minus is bigger, so minus 3. So we have the formula to find the sum. Let's try to substitute here. Sn is equal to n by 2 into 2a plus n minus 1 into d. Okay, so what now we have? We have d, we don't have n, we have a, we have Sn. Okay, so one variable is missing, which is d, which is n to be identified. So let's try to substitute here. 78 n by 2 into 24 plus n minus 1 into d. Do we have d? Yes, we have d. Okay, let me take some space here. Okay, 78 is equal to n divided by 2, 2, 4, 48 plus minus n minus 1 into 3. Let's try to simplify. 78, let's bring this 2 here, which becomes 156 is equal to n. Okay, so let's try to bifurcate this one as well. 48 minus 3n minus into plus becomes plus 3. Okay, n 48 plus 3 becomes 51 minus 3n. Okay, so further we need to push it. Okay, so 156 is equal to n is 51n minus 3, n becomes 3n square. Okay, so let's bring it here, plus 3n square minus 51n plus 156 is equal to 0. So by this, can you identify what exactly is happening? Okay, so can you see the common term in this? 3, yes, it can go, yes, we can say. Let's bring the common term outside. 3n square minus, so 351. How many times it goes? It goes 17 times. Yes, 17n plus 156. How many times? 160. If I say it goes around 52 times, is equal to 0. So dividing both sides by 3, so it becomes 3 divided 0, 0 divided by 3. So it becomes the quadratic equation n square minus 17n plus 52 is equal to 0. So this is a quadratic equation, so we need to solve this quadratic equation. So we should see that the product of this, okay, which should be plus 52n square, we need to find two numbers, and the addition of it should be minus 17n. So what are the two numbers which we can think which can give the product as 52n square and sum as minus 17n? So which table does it goes? Yes, it goes in the 13 fours, right, 52. Okay, so let's try to put it here. N square minus 13n minus 4n plus 52 is equal to 0. Cross check it. Minus 13n minus 4n, which becomes 17n. Okay, minus 13n into minus 4n, minus minus becomes plus, 13 fours are 52, n into n is equal to n square. Okay, taken. So this is fine. So now let's try to solve it further. Okay, so it becomes n, let's take n minus 13 common, let's take 4, n minus into plus, minus into minus, okay, it becomes plus 13 is equal to 0. So we have n minus 4 and n minus 13. Okay, so this means n minus 4 is equal to 0, or n minus 13 is equal to 0, n is equal to 4, or n is equal to 13. Okay, so in this we need to find the n term, so it can be 4 or 13. So let's see at the top what exactly we are trying. So the sum, it to be 78, the term should be either of one of this. Okay, how many terms of the arithmetic progression must be taken? So it can be, let's try to see, let's try to solve it. Okay, further, let me just erase all this. Okay, so assume n is equal to we have a n term, right? So for a plus n, that is 3d. So does it fulfill? A is 24 plus 3 into t is minus 3. Okay, 24 plus minus becomes minus, 3 3s are 9, 9 4 5 16. Okay, I think here there is it should be 424 minus 9, right? So 9 it is, so almost 24, 25, 15. Okay, so this is one value, and what is another value we have got? N is equal to 13. So n is equal to 13. How many terms of the AP must be taken so that their sum is 78? So now, okay, further we can understand with this particular example. Okay, so I'll give you as an workaround. Just try this example with A13. Okay, try to identify this. Okay, so find the answer and see whether this correlates here. Okay, let's move on to the next question. Just before moving forward, I think we will just do one more step here. So we know the values here. Let's see whether adding this we get what value. 24 plus 21 plus 18 plus 15. 4, 5, 10, 18, 2, 3, 5, 6, 7. Oh, perfect. Okay. So we had the SN, right? So the fourth term, so straightforward here, the fourth term. Okay, so they must be taken so that the sum is 78. So sum is 78 means N should be 4. Okay, hence proved. Yeah, let's move next to the next question. Example 14. Find the sum of the first 1000 positive integers. Okay, so let's read our question. Again, find the sum of the first 1000 positive integers. Okay, so the first positive, okay, so it's saying two things here. Positive integers, first 1000. So starting from, for example, 1, 2, 3, like this, 1000. Okay, first 1000 positive integers. Find the sum. So it is saying to find the sum of it. Okay, we need to find the sum. So we have the last term. So last term we have as 1000. Okay, and which happens to be the n values also is there. N value is equal to 1000 as well. The n term or the 1000 term. Okay, so we have a difference. Difference is 1. Do we have A is 1? Okay, so in this case when L is given, so we don't need to we have another formula in fact, so we can find out Sn, sum of the n term is equal to n by 2 into A plus L. So let's try to find out. Okay, Sn is equal to n. What is n? N is 1000 divided by 2. What is A is here 1. L is the last term, so 1000. Okay, 2, 500. Okay, 500 into 1, 0, 0, 1 additional. Okay, so if you multiply 5000 0 zeros would go 500, it becomes 500 500. Okay, so we have found the sum of the 1000th term. So okay, so let's move to the next question. Okay, so let's try to find the first n positive integers. So here everything is similar, and here what I can see is the nth term is not given. So what we can put it, we can put our formula Sn. So n is not aware. Okay, so Sn we know. Okay, let's try to put our formula Sn. N by 2 is equal to 2a plus n minus 1 into t. So we have d. Yes, we have d. Okay, so we have from the previous, so let's try to put it. Okay, so n is not there, n we need to identify. N by 2. Do we know a is the first term? Okay, plus n minus 1. What is the difference? Difference we have seen in the previous example. What is the difference? 1. Okay, see. Okay, n by 2 into 2 plus n minus 1. Okay, so further simplifying this, it becomes n by 2, 2 plus n minus 1, n by 2, 1 plus n. Okay, so either you can write it as n into n plus 1 divided by 2 is your Sn. Okay, so let's move to the next question. Okay students, let's read this example. What is trying to say here? Find the sum of the first 24 terms of the list of numbers whose nth term is given by. Okay, so here what is the question is, it's asking the sum. Okay, sum which is nothing but s of 24 is the question here. Okay, so s of 24, what we have a formula. Okay, n by 2 into 2a plus n minus 1 into d. Okay, so in this we don't have a, we have n, we don't have d. So how can we find? Okay, there is another hint given. So a, nth term, is equal to 3 plus 2n. So it says that an is equal to 3 plus 2n. So if I say first term, if I want to know, here the a is nothing but the first term, right? So if I want to know, I can replace this with 1. a1 is equal to 3 plus 2 into 1, replacing n by 1. It becomes a1 is equal to 3 plus 2, which is equal to 5. So the first term, which is a1 denoted as, will be 5. Okay, so now when we have identified the first term, so we know the a. So difference. Okay, so to find the difference, we need to find the sequence. So how do we find the sequence? Let's try to use the same formula. An is equal to 3 plus 2n. So now let's replace n with 2. a2 is equal to 3 plus 2 into 2, which is equal to 3 plus 2 into 2 is 4, 3 plus 2 7. Okay, so can we find the d now? We have the second term a2 minus a1 will give the d. So d is equal to, so 7 minus 5 is equal to 2. Okay, so we have the d. Okay, so we have a sequence here, starting with a as 5, 7, difference if I put, it will become 9. So like this. Okay, we have the sequence. Okay, so this is the sequence. So now the question is, the ask is, we need to find S24. So S24, let's try to replace this. N we know 24 divided by 2. 2 into a, do we know a? Yes, we know a. What is a here? A is 5 plus n. What is n here? N is 24 minus 1. Do we know the d? Yes, we know the d. D is here, we have identified. So once we understand and get the variables, solving the problem with the formula is quite easy. Okay, so let me just try to push it here. Okay, so 24, 12, it goes in 12. Okay, so 12, 2 5s are 10 plus 23 into 2. Okay, so 12, 10 plus 23 is 46. Okay, 12, 56. Let's go further. Okay, so now we need to multiply 12 with 56. 56 into 12. Okay, so it becomes, how much it becomes? It becomes around
267.
672. Okay, so we got S 24 as 672. So this is how you can. So let's try to understand what have we done. So here the question was to find the sum of the 24th term. So what we did was we wrote a formula to how to calculate these sum terms, and we identified that there are multiple unknown variables, especially the first term is not given, the difference is not given. But there is a hint which is given here in the question that the nth term is equal to 3 plus 2n. So we replace the first term, n is nothing but the position of the element. So if you try to replace n with 1, which is the first position, we got a1, then subsequently we got a2, and from there a2 minus a1 we got the difference d. So with this we could identify the unknown variables, and then we could replace, and finally we could get the sum of the 24th term. Hope this is clear. So let's move on to the next question. Okay student, this is one of the tricky question I can say, and also the last questions to be sorted out in the example. Let's try to read. A manufacturer of TV sets produced 600 sets in third year, 600 sets in third year, and 700 sets in the seventh year. Assuming that the production increases uniformly by a fixed number every year, find. Okay, so this clearly says that uniformly, that means there is a consistency, successive. So here we can see this is an arithmetic progression, and what it says here is sets produced 600 sets in the third year. So assume that the first year is a1, and the third year is equal to a3 is equal to 600, and it says in the seventh year, okay, seventh year, so a7, seventh year is equal to 700. Okay, so do we know a1? No, we don't know, but we know a3 and a7. So in a sequence, if we know certain other numbers in the sequence, we can easily identify it. How? So we have the formula of an is equal to a plus n minus 1 into d. Okay, so let's try to simplify this here. So an, so a3 is equal to, what is a plus, that's what we need to identify. What is n we know n is nothing but 3 minus 1, and the d is not aware. So let's see, a plus 2d. So a3 we know, and also this we know. So a7, by solving a7 we will come to know the other factors. So a7 is equal to, so by looking at this example we can write, see, it will be less than 1. A plus, let's try to solve it for this as well, n minus 1 into d. So sorry, an, so an, so a is not known, 7, this is 7, so let me just put it here, 7. Okay, so a plus 6d is 7. So now we have the two equations. Okay, so this we can solve it and get the value of the unknown value. Okay, how do I do this? Let me move this. Okay, so what is a3? A3 is nothing but a plus 2t, which is nothing but, okay, then a3 can be replaced by 600. Okay, and we have a7, a plus 6d, and we know a7 is 700. Yes, as per the given. Okay, 700. Okay, so let me put it like this: a plus 2d is equal to 600 A plus 60 A plus 6D is equal to 700. Okay, let's subtract it. Positive minus goes, minus sign gets subtracted, 4D minus sign, 600, 700, 100. Okay, minus minus gets cancelled. D is equal to 100 divided by 4, which is equal to 25. Okay, so we know D. So by knowing D, can we identify? Let's take one of the statements here. 1 plus 2, D is equal to 600. So D we know, A plus 2 into 25 is equal to 600. A plus 2, 25, 50, 600. A is equal to 600 minus 50, which is equal to 550. Okay, perfect. We know A is equal to 550. Okay, so we know A is equal to 550 and D is equal to 25. Okay, so the production in the first year is nothing but A1. So this is the answer for this question. Okay, let's move on to so let me just try to repeat here. So by looking at this, as it says uniformly, with this you'll get a hint that is something it's talking about, something which is a common factor here. Okay, so common factors are the common difference or the common increment. What you can see is it's arithmetic progression form. So now it talks about third and the seventh term. So unknown is there, so two unknowns are there. So with this, if we solve it, we'll get the answers for the unknowns. Okay, by making use of those values, we can further solve it. Okay, so let's see the next part of this question. Okay, so now it says the production in the 10th year. We identified first year, so now it says in the 10th year. Okay, so we know the formula A is equal to N. Okay, A plus N minus 1 into D. So here N is equal to 10. So can we find A? 10 is equal to, what is A? So A, we found that it was 550 plus, how do we know? From this 550, this is a continuous of it, 550 plus N. N is nothing but 10 minus 1 into D. What is D here? We identified D as well, 25. Okay, so let's replace this 25. 550 plus 10 minus 1, 9, 25. A 10 is equal to 550 plus. So we need to multiply 9 into 25, which will be 7, 9 to 5, 5, okay, then 2, okay, so it will be 225. Okay, so adding this will become 5, 7, 7. A10 is equal to 775. Okay, this is the answer for this, the production in the 10th year. Okay students, now let's move to the next question, which is the final and the last question in these examples. Okay, so the total production in the first 7 years. So when it says total production is nothing but the sum, it's asking for the sum in the 7th year. So the 7th year sum it is asking. So we have a formula S n is equal to n by 2 into 2 n minus 1 into d. This is the formula what we have. In this, what do we know? Okay, do we know n? Yes, we know n. N is nothing but, let's try to put it, n is equal to 7 here. Do we know A is equal to 550? How do we know? You can check it out here. 550, we know D. D is nothing but 25. D is equal to 25. What are the other variables? N we know, A we know, D we know. So let's try to solve this and we should be able to get the answer. S7 is equal to N7, 7 divided by 2, 2A plus N. Sorry, we have A, let's replace A with this 550 plus N, which is 7 minus 1 into D, 25. Okay, so let 7 divided by 2, 2, 5 multiplied, it becomes 1100 plus 6 into 25 is equal to 7 divided by 2 to 1100 plus 625 is a 150. Okay, 7 divided by 2, so this becomes 1250. So 2 goes in this, how many times? 6, 25. Okay, so further solving this, 7 into 625. So S7 multiplied by this, it becomes 5, 7, 3, 4. So this is the sum of the numbers. So here we identified the total production in the 7th year is 4375. With this, we have completed all the questions and hope you had solved along with this. If not, please have a look and please turn around and try once or twice. You will get to know. My input would be to read the questions more than once and try to divide the question in parts and try to analyze and sort it out. So most probably you will get it. If you don't get it, try multiple times. It should be able to sort it out with respect to it and understanding. Okay, and if you see, most of the problems are turning around towards the nth term or towards the sum of the terms. Hope you have enjoyed this. So let's thanks for watching this, and let's have a next section in the upcoming. Please do let me know what exactly the topics you would like me to cover. Thank you. Take care. Bye.